Good morning. It's an honor to share one of our applied research experience on the Tothian theory. This presentation was created by Maribel Manzo, Armando Perez, and myself. My name is Alessia Kachadourian. Thank you for being here to discover real solutions from Tothian theory. Maribel and me, we will be presenting. To begin with, let's put on the table some facts to connect groundwater, environmental impacts, and sustainable design. If we carefully and correctly read the official data in Mexico, groundwater is the main source of water. In general, authorizations, private master plans do not fully and correctly consider groundwater dynamics and how the relevant environmental impacts and even sustainable design beyond the certifications are conditioned by groundwater dynamics and also water supplies. Water capacity is often presumed from very light and limited hydrogeological studies. And in addition, when the projects have their own groundwater wells, their actual performance is assumed to be perpetual, and doesn't exist an evaluation of the groundwater dynamics and well sustainability. Moving on, we want to remember three key points that bring us together as groundwater dynamics researchers. Number one, because of the natural distribution of what we call fresh water. Number two, around the world, we are living the negative consequences of not correctly integrating groundwater dynamics into the design and operation of policies, plans, and projects. And this is happening across all sectors. And number three, as humanity, we are facing the need to redesign and operate our activities centering water and people in systemic life understanding. And all this can be understood applying the Tothian theory. And this is fundamental because today the Tothian theory is the scientific paradigm that facilitates the hydrological evolution of landscape, environment, and water supplies.
Well, I am a geological engineering, and during my studies, I learned about traditional hydrology. In this approach, groundwater is considered to exist in confined aquifers, seen as separate units. Surface water and groundwater are also treated as two different systems, but this approach was useful in the past because it doesn't fully explain how water moves in nature. With the Tothian theory, we see water as a single system and indivisible unit. And for me, this is a big change. Before, I see water as many separate aquifers, and now I see it as one system with no real boundaries. And something that also surprised me was the applications. We can use this theory in real projects like hotels and buildings. And also, this theory is not just a scientific concept. It can be applied to real problems. And for me, was very exciting to see these applications in real life. Now, let's see how these ideas were applied in a real case. This was my first hydrological project using Tothian theory. And the project is located on the Mexican Pacific coast in an area recognized by the New York Times as one of Mexico's top tourist destinations. The site is covered by tropical forests and is so close to an important natural area with high ecological and hydrogeological value. And this combination with high tourist pressure and protected natural area makes water management here especially really important.
So the challenge of this project was not only its location, but because at the first inspections, it seemed that there was not too much to contribute from our modern hydrogeological analysis that we develop here in UFlows. This project has a qualified team with a solid master plan and with all the permits by the Mexican government. And they had water, and it's located in an aquifer without legal restrictions. But the developers of these projects are innovative and keep asking for more. So the objective was to evaluate beyond the conventional ideas to check if they were seeing the whole picture of the water dynamics and to discover how under the surface of the project it is connected to all the treasures that they want to protect: the Pacific Ocean, the rainforest, the landscape, and the beautiful view, and of course, the high water quality that they have. So they decide with us to review the project from the glasses of the Thothian theory. On this slide, we are looking the big photo of the methodological process we that we follow in this project. We always start from what we see on the surface, and maybe it's because it's where we live. Collecting the hydrogeological clues called surface indicators and establishing the hydrogeological context that is integrated by the biggest factors that develops the regional groundwater flow system. To achieve the goal of understand the key connections between groundwater dynamics and sustainable design and operation of the project, we develop a parallel process of environmental impact assessment. This project is in progress, and we already conclude the phase 1, and we will start the phase 2 with the client.
Well, traditionally, hydrology focuses only on rocks. In this study, we use a more complete approach. We consider the rocks, the climate context, and the relief to understand how groundwater moves. And this picture shows a cross-section from the Pacific Ocean to the low hills. And one important part is the hydrogeological basement. It's made of granite and its depth changes from a few meters to about 2.5 kilometers. The basement is important because it controls the limits of groundwater flow. In this area, evapotranspiration is higher than rainfall during most of the year, so this water could be coming from a regional groundwater flow system. To build this model, we use geophysical studies, climate data, and a digital elevation model. We validate much of this information with civil engineering tests, such as the standard penetration test. And we look at the system as a whole, with rocks, climate context, and the relief, so that we understand is not a separate parts, but is one integrated system.
At the same time that we were doing the hydrogeological context, we started also to collect the clues that the groundwater flow system leaves on the surface. We really love the surface indicators because they can be so clear and easy or not. Depends on how accurate do we have the information and the knowledge about the trees, the vegetation, ecosystems, and soils. And in this context of a tropical rainforest, they are not so easy to find directly the surface indicators. But we discover that construction engineer data can be a surface indicator, a very clear indicator, like the standard penetration test and infiltration points. Even when we have some strong surface indicators, like this engineered data, but also the groundwater deep, we always have to validate on the field. We went to the field and looking the micro environments where are located the groundwater wells, we collect a lot of information. Also the status of development of the tree, and also how is the behavior of the creeks and the small rivers that they are in the zone, where are really strong surface indicators. Well, a key contribution to the project for the architects and engineers was that during the field work, we were identifying with them the hydrogeological features that had previously been overlooked by focusing only on the slope and runoff. That is a very common practice on the hydrogeological study. But we identify the discharge zones, and was great, a great aid for the architect and for the architecture design and the construction locations, and also to modify some of the buildings, because with the architects and the engineers, we confirm that in these discharge zones, they have more risk. We are talking about more humidity, more risk of landslide, and so on. So the identification of discharge zones help not only to understand the groundwater dynamics that they are sustaining the ecosystems, but also to rethink with the developers the opportunity to relocate some buildings and also the access points and the pathways. And another contribute that we didn't expect was that the distribution of the different manifestations of the hydrogeological process controlled by the regional groundwater flow systems were the ecotones to design the landscape. So here we have some of the findings that transform the unseen aspects into resources for sustainable design. Thanks to the application of a systemic understanding of water guided by the Tóthian theory, it was possible for this project do the transitions from water being regarded as a hazard to being acknowledged as a fundamental component of sustainable design. Typically, architects and designers and engineers, they have the conscience that they have to integrate the water dynamics. But in general, there is not the knowledge how to integrate correctly. With this process, we were allowed to visualize with them how important are the groundwater wells for the developers of the project, because it's gonna be the life source of the project, and how they are a key agents of change. And for us also, as a groundwater dynamics research, the result of this study allows to us to reflect how the groundwater wells, when they are functioning water source, for us is a entry for a real hydrologic sustainable design, and to develop scientific research on regional groundwater flows system. Finally, we want to share another key results and open questions to guide future research. Innovative architecture and construction can be developers for hydrogeology modern research, guided by Tóthian theory. And this is not because they love scientific hydrogeologists, but because we can be a really strong element for strategic decisions making, like with their water supplies, in this case, groundwater wells, but also for evaluate the locations of the buildings and the operations, integrating how is going to be the territory control for the rest of the life cycle of the project is going to be controlled by the groundwater dynamics, because of the functioning of the regional groundwater flow systems. And at the same time, they are going to be playing with the operation of the groundwater wells. A key finding for us is that the Tóthian theory is a great aid and facilitator of scientific progress, and to identify and implement the change that we have to make to reduce environmental impacts. And the implementation of this change starts on the design phase of a project. And please, another thing that we want to share with you is that maybe it's a good reminder for everyone that we need to integrate the groundwater wells operations, because they are crucial for understanding how are working today and in the future the regional groundwater flow system. And we hope that this experience that we are having now here in Mexico can be useful for you to stimulate to develop the modern hydrogeology followed by the Tóthian theory that responds through groundwater wells efficiency, sustainable design and operations of a project buildings, and most for the preservation of life. Thank you very much.